Dear students, nowadays we are revising about atoms and molecules. And in the chapter Atoms and Molecule, first we revised about the main postulates of modern atomic theory. Then atom and atomic mass, how to calculate relative atomic mass based on carbon-12 scale. Then some examples of relative atomic mass of elements based on the carbon-12 scale. How to calculate average atomic mass using the formula of average atomic mass is equal to mass of first isotope into its abundance plus mass of second isotope into its abundance. Then isotopes of oxygen and the classification of molecule based on the combination of atoms and what is atomicity, how to classify the molecule based on atomicity, then how to calculate average atomic mass using the mass and its abundance, then classification of molecule based on atomicity, whether it is a diatomic, triatomic, polyatomic, and a relative molecular mass based on carbon-12 scale. Then the differences between atoms and molecule, mole concept, which explains about the number of atoms or number of molecule present or number of particle present in a given amount of substance. Then what is Avogadro number? The value of Avogadro number, it is 6.023 10 power 23. And what is molar volume? That is the volume occupied by 1 mole of any gas at STP. The value is 22.4 liter or 22,400 ml. Calculation of moles using different modes, that is mass by atomic mass, mass by molecular mass, number of atoms by Avogadro number, number of molecules by Avogadro number. Then person composition, this can be calculated using the formula of mass percentage of an element equal to mass of the element in the compound by molar mass of the compound into 100. Then Avogadro hypothesis, which is nothing but which relate the equal volume of gases to the equal number of molecules. Equal volume of all gases at STP contain equal number of molecules. Then applications of Avogadro law, 5 points. Then relation between vapor density and molecular mass, that is the relative molecular mass is equal to 2 into vapor density. Then there are some solved problems are there. Using the given formula, we have to find out the answer. First one, molar mass. How to calculate the molar mass? Using the formula, molar mass is equal to N into atomic mass. That is, N is number of atom into its atomic mass in the compound. Then calculation based on number of moles from mass and volume. When mass of the substance is given, you can use the formula number of moles equal to mass by atomic mass. At the same time, when the given substance is in the form of molecule, you can use number of moles equal to mass of the given compound by molecular mass. That the given substance is in the form of volume, for example 5.6 liters of oxygen, which is in the form of amount volume. So given volume by molar volume. Molar volume is a constant determined volume, that is 22.4 liter at STP. Then calculate the mass from the mole. It's the same. The formulas are same, and we are going to modify the formulas then and there to calculate mass or number of atoms. First, you have to find out number of moles from the given amount of substance. The amount of substance is suppose 0.3 mole of aluminium means the mass of aluminium by atomic mass of aluminium, and mass is equal to find out mass we have to modify the formula. Mass is equal to number of moles into atomic mass. So mole is given 0.3, atomic mass of aluminium is 27. Atomic mass can be referred using the periodic table. The modern periodic table, atomic number, atomic masses are given. Also some of the examples are given in the book itself. You can refer, or the Clerk's table log book also contain this atomic masses of the element. Then of atoms and molecule. So how to calculate the number of molecules in 11.2 liters of carbon dioxide at STP? Number of moles is equal to volume by molar volume. The given volume is 11.2 liter of carbon dioxide. Molar volume is determined constant value 22.4 liter. So 11.2 divided by 22.4, you can cancel 1 by 2 will come. 1 by 2 is equal to 0.5 mole. So mole is obtained. From the mole, you have to calculate the molecule. That is, the number of molecule is equal to mole into Avogadro number. Avogadro number value is 6.023 10 power 23, which is a constant value, determined value. You have to multiply the obtained mole by with 6.023 10 power 23, and you will get 3.011 10 power 23 molecules of carbon dioxide. The next one, say calculate the number of atoms. Same formula. First you have to calculate number of moles, mass by atomic mass. Here in the formula it is given comprisingly with the Avogadro number also. You can also do it separately. Number of moles equal to mass by atomic mass. Then you can multiply the number of mole into Avogadro number. Or you can use the formula like mass of the given substance into Avogadro number by atomic mass. Similarly, in the next sum, calculate the number of molecule. Same formula, mass by molecular mass. Whether it is atom, mass by atomic mass. Whether the given substance is in the form of molecule, you can use mass by molecular mass. Here, 54 gram of water. Water is a molecule. So you can write 54 divided by molecular mass is 18. 54 divided by 18. Then you can multiply by the Avogadro number after calculating the number of moles. Then calculate the number of atoms of oxygen and carbon in 5 moles of carbon dioxide. Normally, 1 mole of carbon dioxide contain 2 moles of oxygen. Say CO2. That CO2, see, 2 oxygen is there. So 5 moles of carbon dioxide contain 5 into 2, 10 mole of oxygen. 10 mole of oxygen. Then number of atoms equal to number of moles into Avogadro number. 10 mole of oxygen is there in 5 mole of carbon dioxide. So 10 into Avogadro number, that is 6.023 10 power 24. The 10 is used to increase the power of 23 to 24 atoms of oxygen. Then from this, number of atom of carbon, similarly number of moles of carbon into Avogadro number, 5 moles of carbon into Avogadro number, that is 3.011 in 10 power 24 atoms of carbon. Then how to calculate the molar volume? Molar volume can be calculated by the formula given volume by molar volume. Given volume is, suppose 1 liter, 2 liter you can write, but here see 2.5 mole. Mole is given. So you have to write the number of mole place, you can write 2.5 mole. given volume you are going to calculate, and the molar volume is already given, that is a constant determined value 22.4. So volume of carbon dioxide at STP is equal to mole into molar volume, that is 2.5 into 22.4, that is equal to 56 liters. Similarly, 3.011 10 power 23 ammonia gas molecule. So first you have to calculate the mole. To calculate mole formula, number of molecule by Avogadro number. Suppose if it is gas, you are going to write number of molecule by Avogadro number. All the elementary gases are going to be, gaseous substances are going to be in the form of molecule. Suppose atom, you can write the number of atoms by Avogadro number. But here ammonia is a molecule, that is a number of molecule by Avogadro number. So the value of ammonia gas molecule is 3.011 10 power 23. The Avogadro value is 6.023 10 power 23. When you are going to cancel 1 by, you can cancel, that is you will get 2 moles. 2 moles will be obtained. So the volume occupied by ammonia is number of mole into molar volume, that is 2 into 22.4, 44.8 liter at STP. Similarly, 14 gram of nitrogen gas. First you have to calculate mass by, so the sum, next to sum 14 gram of nitrogen gas. 14 gram mass is given. What is the formula to calculate the number of moles from mass? Mass by molecular mass. 14 gram of nitrogen. Nitrogen is in the form of molecule. So 14 is the given mass. Atomic mass of nitrogen is 14, but in the nitrogen gas, N2 is the formula. So 14 into 2, 28 will come. So 14 by 28, you will cancel that 1 by 2, that 0.5 mole. Then volume occupied. What is the formula to calculate the volume? Number of moles into molar volume. Number of moles calculated is 0.5 mole, and its molar volume, constant molar volume is 22.4, so 11.2 liter. Then calculation based on composition. So how to calculate? There is a formula to calculate mass percentage of the element is equal to mass of the element divided by molar mass of the compound into 100. Formula is already given in the book. That is, mass of the element is equal to, mass percentage of the element is equal to mass of the element by molar mass of the compound into 100. Here they asked to find out the mass percentage of sulfur in sulfuric acid. Sulfur, S is sulfur, H2SO4 is sulfuric acid. So in the H2SO4, 2 hydrogen atoms, 1 sulfur, 4 oxygen atoms are there. So you have to first calculate the molar mass multiplying the number of atom into its atomic mass. So 2 atoms of hydrogen, its atomic mass is 1, so 1 into 2. And 1 atom of sulfur, atomic mass is 32, so 32 into 1. And there are 4 atoms of oxygen, so 4 into its atomic mass 16. And you have to get the sum of all these values, multiplied values. So 2 plus 32 plus 64, that is 98 gram is the molar mass of sulfuric acid. That you have to write as a numerator. So mass of sulfur is 32 in the given compound. So 32 by 98 into 100 by, so when you are going to cancel, you will get 32.65 percentage of sulfur is present in the 98 gram of sulfuric acid. 98 gram of sulfuric acid. And also there are some exercise, sums are there. I will send the sums along with this topic. You have to practice and you have to find out the answer using the formula and write down in your notebook with the formula. First, when you are going to do the sum, first you have to write the sum, then you have to find out the formula to calculate the mass or mole or number of molecules or number of atoms. Then you write the formula first, then substitute the value and bring out the answer. write the answer with the correct unit. Then in the points to remember, it is given two or more forms of an element having the same atomic number but different mass number is called isotope. That already you have revised in the modern, that is the postulates of modern periodic. That is what is called isotope. Atoms of same element, chlorine, same element, same atomic number but different mass number. So this is called isotope, isotopic elements. And similarly, what is called isobar, atoms of different element with the same mass number and different atomic number. Here different elements are given, argon and calcium are different element and their mass numbers are same, 40 their mass number, and atomic numbers are different, 18 20. So these elements are termed as isobars. Similarly, one more term is there, what is called the isotones. Isotones are different from the isobar and isotope. Different element, different atomic number, different mass number. All the three terms are going to be different. And carbon and nitrogen, two different elements, and their atomic numbers are 6 and 7. Difference is there, and mass number also 13 and 14. So what will be the similarity in this case? The number of neutron will be same. When you are going to calculate the number of neutron, what is the formula to calculate number of neutron? That is number of neutrons equal to A minus Z. This is the formula. Number of neutron N is equal to A minus Z. This already you have learned in 9th standard. That is mass number 13 minus 6. That is 7. 14 minus 7, 7. So for all these two atoms, the number of neutron is same. In the nucleus, the number of neutron is same. So the atoms have different element having different atomic number, different mass number, but having same number of neutron is termed as isotones. So you have to revise all this, and in the next class you will see the textbook evaluation, and along with this topic you will be given some of the problem to solve using the formula. You have to solve the problem and write down in your classwork, and we will see the textbook evaluation, that is choose, and next fill in the blanks, match the following, true or false. All these things we will discuss in the next class. So till that you have to practice all these sums, and formulas are important. You have to write the formula, learn the formula. Formulas are more or less going to be similar to one another, and modifying, we are going to modify the formula to find out the which factor is asked. So you have to remember these formulas and do the exercise and practice well, and also take down in your notebook. So do it, don't be lethargic, and practice well. Thank you. We will see you in the next class.